Yo, Wendy, where are you going?
We have to go test this batch to make sure it's methamphetamine.
Why? It looks blue enough to me.
You idiot, it's because you brought the wrong ingredient.
Jesus, man, I didn't even know. They all look the same.
Well, we have to go test this batch now.
How?
We gotta use infrared spectroscopy.
Oh, yeah. What's that?
I'll let Wendy's, Junior, and Skylar explain that.
Okay.
Well, Jessica, IR spectroscopy is a technique that identifies the functional groups within an organic compound based on characteristic absorptions of specific IR frequencies.
But for it to work, the vibrations of the molecular bond must cause a change in the dipole moment.
Wait, what the fuck does that mean?
Well, bonds can either stretch or bend, causing a shift in the electron density and a change in the magnetic field. If the IR that the molecular bond is exposed to has a frequency that matches the frequency of the changing magnetic field, then IR radiation is absorbed.
Yeah, science!
You don't even understand that, did you?
Well, that's not as important as being able to interpret the IR spectrum. Let's run an IR. First, we'll need to do a background check.
So why do we need to do a background check?
Any substance above 0K emits infrared radiation, so we need to subtract the background radiation from the sample radiation.
Correct. And now we need to prepare the sample. Wendy, Junior, if you will. Since our sample is a solid, we have to grind it up before we swab it onto the IR spectrometer. Our IR spectrometer uses nichrome wire as the source of IR. The sample is swabbed onto this prism here, and when the IR beam enters the prism, it bounces off the surface in contact with the sample. The sample then absorbs the IR radiation.
The IR the sample absorbs is then detected by triglycine sulfate, which works similarly to a phototube, and we can obtain an IR spectrum.
Wait a minute. Where's the secondary amine stretch? And where's the aromatic ring stretch?
Oh, as if I know.
5% yield, what are you doing?
Yo, Wendy, this is sweet. You should try some.
Jessica, do you know what we made?
What?
We made rock candy. How did we make rock candy?
Oh, as if I know. So what are we gonna do with it now?
Do you have the product?
Yes, we do.
This looks different than normal.
That's because it's more pure.
This is sugar.
She fly It's 96% pure.
We'll give you a discount if you give us an A.
I suggest you go throw them out in trash.
Well, bonds can either stretch or they can bend, causing a shift in electron density and a change in the dipole moment. This causes a change in the magnetic field. If the IR...
Probably have to read.
But for it to work, the vibrations of the molecular bonds must cause a change in the dipole moment.
Our IR spectrometer uses nichrome wire as a source of IR. The sample is swabbed onto this prism here, and when the IR beam enters the prism, it bounces off the surface in contact with the sample. The sample then absorbs the IR.
I'm sorry.
Oh no, Rika, don't apologize.
Shit, what was this?
That's all, folks.